All right, this is the semester exam review for Chapter 6, and we're going to start off with some composite functions. So letter A, we're given these two functions f and g, and the way this is written, this is the composite of f and g, but g is going to be used as an input into f. All right, so the f of g composite, I'll just say f of g of x would look like this. In the f function, we will do the square root of 6 times 3 plus x. Then we'll simplify that, and that's going to be the square root of 18 plus 6x after we do the distributive property. And then we have to state the domain. So we got to be careful with radicals. We can't input a number for x that would cause this number underneath the radical to be negative, since this is a square root. And so to catch that number, we're going to set this little inequality up so that we can identify what those numbers should be that are okay to be input in for x. And so we would subtract 18 from both sides and divide by 6 on both sides. And so all the numbers greater than or equal to negative 3 will be a part of our domain. So there's the f of g. And now we'll do the g of f. And now it's just going the other way. The f function is going to be used as an input into the g. So in place of x, I'm going to put the square root of 6x. And again, we can't combine those, so we just have to be careful that we do not create any negative number underneath the radical. So x could be 0 or anything greater than 0. So our domain here is just going to be from 0 to positive infinity are acceptable numbers that can be used in that composite. And then finally, we'll do the f of f, which means we'll just turn around and put the f function in place of x in that same function. And that is really all we can do with that. And then we will state the domain, and it'll be the same. We just can't let this be anything negative. So the domain is going to be any number that is greater than or equal to 0. All right. Number 2, the function f is 1 to 1. And so we're supposed to find the inverse of the function. So to find the inverse, we switch places with x and y. And then we solve for y. So we raise both sides to the second power. And then I'm going to add 4 to both sides. And then when you get to the point where you have found the inverse, I'd like for you to use the notation. This means we started with f and we've come up with the inverse of f. All right, and so I'm going to graph the function. So this is the square root parent that has been shifted 4 units to the right. So all the points on that quadratic parent. So 0, 0, 1, 1, 4, 2 moved 4 to the right. And that's really as far as we need to go. So there's the the square root parent. And then we're going to graph the inverse. Now, in its entirety, this would be a parabola, but we're not going to graph the whole parabola. We're just going to graph the right half of the parabola. So we could say for x greater than or equal to 0, because doing the whole parabola would mean we'd have a whole parabola opening up to the right, and we don't have that. So to make it match this original function, the inverse is just half of that parabola. And so you can do that by just taking these ordered pairs off of the red. So 4, 0 becomes 0, 4. 5, 1 becomes 1, 5. 8, 2 becomes 2, 8. So anytime you want to get the points for the inverse function graph, you just take points off of the original and you switch the coordinates. And then we're supposed to also graph y equals x. And there's our finished answer for number 2. All right, and now we get into some log problems. So we're supposed to write each expression as the sum or difference of logarithms. So in other words, we're going to expand these, and all powers are going to be brought down and used as factors, and that's just an application of the power property. Okay, so in the numerator, I'm multiplying 3 different things together. So this is the product property. It says the product of the log of a product becomes the sum of the individual logs. So log base 6 of 7 plus log base 6 of x to the third plus log base 6. And you always want to change radicals into rational or fraction exponents. Okay, and now to do this second part, express powers as factors, we'll need to use the power property. So 3 comes down and is used as a factor here, 3 times log base 6 of x. And then this is 1/2 times log base 6 of z. And that ends up being our answer for number 3. All right, so the same thing here. I'm going to change, I'm multiplying these two together, so I'm going to break these up as the sum of 2 different logs. And we need to rewrite the square root of x squared minus 3 as x squared minus 3 raised to the 1/2 power. And since I'm dividing, I'll be subtracting natural log x minus 2. So the only thing to fix is this power needs to be written as a factor. So again, this is the power property. And there's our answer for number 4. And now we're going to go the other way. So this is putting 2 logs together. And so to put 2 logs together, we're basically going to do the power property, but in the reverse order of what we did before. These factors are going to be used as exponents. So this is log base 5 of x to the 12th, and that will be raised to the 3rd. And this is going to be log base 5 of x to the 1/2. Always change radicals to rational exponents, and that'll be raised to the 1/8. So log base 5 of x to the 36th power. And this is log base 5 of x to the 1/16th power. All right. And to put these two together, since I'm adding, This is the product property, so I'm going to put these together as one single log using multiplication. And now I'm going to put these two x's together. Since they're the same base, I write this as one single x and I add the exponents together. All right, so we got to get a common denominator for 36 and 1/16. So 36 times 16 is 576. All right, so I'm going to change this to x to the 576 over 16. And then, of course, this is already in 16ths. And I'm running out of room, but I put those together as, come down here at the top of this, log base 5 of x to the 577 over 16 power. And I'm okay with you leaving it like that, but if you did apply the power property, you would just bring this exponent down and it would look like that. But I would accept either one of those answers. Okay, and here we are subtracting two logs, so this is the quotient property. The log of the difference becomes the quotient of the logs. And in cases like this, you want to make sure you've factored fully because it may be possible to reduce. So there's the factored form of the numerator. And there's the factored form of the denominator. And sure enough, we are able to cancel. So my final answer here becomes log of x minus 6 over x plus 2. All right, 7 and 8, we're solving these equations, and this is going to be the common base technique, and so I need to rewrite 27 and 9 using the same base number, and that base number is going to be 3. So 27 is 3 to the third, and 9 is going to be 3 to the second. And now that I've got common bases, I just let these two exponents equal each other. Just make sure you do the distributive property correctly on this left side. And we solve for x, so 6x is negative 10. So x is negative 10 6, which reduces to negative 5/3. All right. So here I'm going to make my common base become 2. This common base, by the way, has to be a whole number greater than 1. It can't be a fraction between 0 and 1. So I'm going to let 8 become 2 to the third, and that's going to be raised to the x minus x squared. And then 1/2 is 2 to the negative 1. All right, so distribute the 3x minus 3x squared equals negative 1. And it looks like we're going to have a quadratic equation, so I'm just going to let it equal to 0. I'm going to add 3x squared and I'll subtract 3x. I just like for my quadratic coefficient to be positive. You could have multiplied by negative 1 if you left it on the left side. So you just pick a method. Factoring isn't possible. So, and I didn't, we did exact form here. We'll do decimal form in this case. So let's go ahead and use the quadratic formula. So opposite of b plus minus b squared minus 4 times 3, which is 12, times negative 1, that's negative 12, all over 2 times 3, which is 6, 3 plus minus the square root of 21 all over 6. Okay, and that would be the exact answer. And now let's just go to our calculator and we'll get the decimals rounded to 3 decimal places. All right, so I'll go to my calculator. And there's our final answer. So exact form and then decimal form rounded to the nearest thousandth. All right, got a couple more. These are log equations, and so I'm going to get the logs together on the same side so I can use one of my properties to put them together. So log base 6 of x plus 3. So I'm going to add log base 6 x plus 4 to both sides. And now I can use the product property to make them come together as one single log. So you always want to make multiple logs become one. And I'm going to have to do FOIL on these x plus 3 times x plus 4. So that's going to be x squared plus 7x plus 12. And now that I've got single log equation form, I'm going to change this into exponential form. So the base of 6 raised to the power of 1 is going to equal x squared plus 7x plus 12. And we got another quadratic equation, so let's make it equal to 0 by subtracting 6 from both sides. And when I solve this using factoring, I got x plus 6 times x plus 1. So I got 2 possible answers. But you got to keep in mind when you're doing these log equations that when we plug a number in for x, we cannot create the log of a negative number. That's what will happen if we plug -6 in for x. And it doesn't have to make both of these negative. As long as it made one of them negative, I couldn't use it as a solution. So -6 creates a problem. It creates the log of a negative number, so I'm tossing -6 out. -1, however, would make the log base 6 of 2. That's fine. And then log base 6 of 3. Neither one of those are negative, obviously, so my answer is just going to be x is -1. Okay, so if I have an exponential equation base e, I need to turn that into a natural log equation. So in natural log form, it's going to be the natural log of 2 equals the exponent 5 plus 4x. Just remember that basically logarithms are exponents, and so when I write the log equation form, I need to let it equal the exponent. And so now you can just go to your calculator and we're going to find out what natural log 2 is. And no reason to write that decimal down. I would just leave it there. It's 0.69314718006. And now just go through your routine. You're going to subtract 5 from that number, that decimal. And then you're going to divide by 4 that number. And our answer for x is to the third decimal place, it's -1.078. And that does it. That takes care of this review, some log review, some inverse function review, some composite function review, a lot of good stuff, helpful stuff in this chapter. So I hope this helps you as you hopefully you're preparing yourself for the semester exam. But if you have any questions, let me know.